Good day, friends. Welcome back to Smart Book Guide. In today's video, we are going to be looking at a question on potential difference, right? So, the question says that determine the absolute potential in air at a distance of 3 centimeter from a point charge of 50 nanocoulomb. So, the first stage is that what is the concept or what is the idea about the word absolute potential, right? This is where it comes from. Assuming that we have a charge Q, right, which is a positive charge. We know Q is a positive charge and it is going to give us an electric field which is going out this way, right? One thing you need to look at here is that since it is giving us Q, which is going out that way, right, which means all here a positive charge, why the ending part should be negative, as the concept of electromagnetic used to go, right? So this line is the what electric field. Now, if we have another charge, which is a test charge, Q naught, which is also positive, right? If we take this charge and put it inside this electric field, right? If we put it inside this electric field, right? What happened here is that it tries to what attract towards this negative side because positive charges attracts what negative charge, right? But the positive charge and positive charge they repel, so it tends to what to want to attract with the what negative charge, which means it tends to what go into this direction, right? Now that's not what we want. Have they been, let's say, we want to make this positive charge, since we know that this positive charge will also like to go this way, right? What if we want to take the positive charge, we want to move it backward like this so that it will repel with the positive charge, which is this one here, you know, because positive they repel. So which means there has to be a work done that we have to do so that we'll be able to move the charge from this negative side back to the positive charge. So which means we are having something like this positive and this positive Q naught. This one is going out. You know, this one too also should be going out, but we are forcing it to be going this direction, right? Which means since we are forcing it to go into this direction, right, then work done has to take place. You get the point? That's where we are getting the idea about potential from. It is that work done. So meaning that let's assume that this point here is point B, which is where our charge is located, is point B, and this is point A. So we are trying to move the charge from point A to point B, right? So if we are trying to move the charge from point A to point B, then definitely work have to be done, right? And the idea here is that in moving the charge from point A, which is this point, to point B, right? Since you know it is going the opposite direction, work done is happening. So now, one thing we need to understand here is that, or I should put it this way, the general case study or the overview of this concept here is just trying to say that what in moving a charge, right, from a point to another point, opposite to what the electric field. So you are trying to counterpart it, right? So if you are doing that, then definitely you are doing some work. So when we have, let's say we have a point A, right, then we have a point B, right? The work that needs to be done to move this charge, because this electric point A is giving us like electric field as we explained the other time, right? So if we're trying to move a charge which is also positive, which we know should be going this direction, but no, we are not making it go this direction, rather want it to go this direction, which means it has to be repelling, there has to be some force that happening, so there has to be work done. Now the work done due to this charge here, which means the work done due to Q naught, which is this charge here, is said to be what? The potential difference between the point A and point B. Let me come again. The work done, right, in moving a charge, this Q naught, right, from point B to point A is said to be what? Potential difference. Let me write it down. Potential difference, right, between from point B to point A or point A to B, right, is said to be the work done over Q naught. Now, there are some calculations that goes behind it from the proving, but in a short form, it says that if we have 2 points, point A and point B, right, which is the potential difference, now the work done has to be equal to Q over 4 pi epsilon naught, right? Open bracket 1 over Ra minus 1 over Rb. Now, what this simply means that in moving a point charge from point B to point A, right? From B to A, right? Then definitely to move it from point B to A, meaning that VAB is equal to VA minus VB, right? Then the relationship between VA and VB is this. So here's the general formula we use. Let's say we have a potential difference, right, between 2 points. This is the formula we are going to use. It says that VAB, which is the potential difference between A and B, that means from B to A, equals to Q over 4 pi epsilon naught, open bracket 1 over Ra, which is the distance from the point to point A, right? So, and then Rb, that means where the charge is residing to the point A. So let's look at this problem that we are being given, and let's see what we can do with that formula. We said that now the question says that we should determine the absolute potential, right? Now we are given the distance to be what, 3 centimeter, and the point charge to be 50 nanocoulomb. So since we are given that, what we need to do here is that we write down the given, right? The given here is that R equals to what? 3 centimeter, and then Q equals to 50 nanocoulomb. We can convert this R equals to what? 3 times 10 to the power of negative 2 meter, and this to what? 50 times 10 to the power of negative 9 coulomb. Now we are asked to find absolute potential. Now the difference between absolute potential and potential difference is this, right? So since we know that this one is the overall formula, right, for 2-point charge, the absolute potential is saying that what if the point B, where the charge is coming from, right, is set to infinity. Look at it. Here is point A. Here is point B, right? We are moving the charge from point B to point A. Now, assuming this point B is at infinity, which means we don't know exactly where will point B be, right? But we know we have point A. Just like dropping a ball of a stone at one point and trying to feel the kind of force from the stone from a far distance, right? Though we have a reference point. So which means if the point B, which is where we are bringing the test charge from, which is Q naught from, right? Because we are bringing Q naught from somewhere. So assuming B tends to infinity, then definitely if B is to infinity, then RB has to be infinity. Then if RB, which is the distance, is infinity, then 1 divided by infinity is 0. So all this thing here becomes 0. And if it becomes 0, we end up having VAB equals to Q over 4 pi E naught, right? 4 pi E naught, then 1 over RA minus 0. But one more last thing we need to do here is that we don't say VAB because we have eliminated B from the equation. So we end up having VA, right? Which is the potential or absolute potential, right? Which is the absolute potential, and that's what we are asked to look for. So what we need to do here is that we need to just take the formula and say VA, or we just name it at V because it is just 1, right? Equals to what? Q over 4 pi epsilon naught 1 over R A, right? We can change this as becoming what? K, because we know the idea about this, right? K, which is a constant, right? Then we have Q, which is this charge here. We have this charge Q, right? 1 over 4 pi epsilon naught is K, which means this K is 1 over 4 pi epsilon naught. Then this Q is this Q. Then RA is RA. So therefore, we can say the formula for the absolute potential of this problem is V equal to K, which is 1 over 4 pi epsilon naught, then Q, which is the charge, over RA. So all we just need to do is substitute. K is a constant, and it is having a value of 9 times 10 to the power of 9. Then Q is a positive charge, right? And it is having a value of 50 times 10 to the power of negative 9 nanocoulomb. Then RA is having a value of 3 times 10 to the power of negative 2. So let's keep simplifying. Then we say that's what? 9 times 50 times 10 to the power of 9 minus 9 divided by 3 times 10 to the power of 2, negative 2, right? So I can simplify this more as saying equals to 9 times 50 over 3 times 10 to the power of 9 minus 9 plus 2, because once you take this negative minus here, upward becomes positive. So we're just trying to simplify it. Then we end up having 3 here 1, 3 here 3 times. So we have 3 times 50 times 10 to the power of 2, because 9 minus 9 is 0. Then plus 2 is this. So we have 150 times 100. That ends up giving us 15000, right? So the value is what? 15,000. Now it is a potential difference, and the unit is volt, right? Definitely the absolute potential is what? 15,000, which is 15,000, right? I hope the idea about this question is, I hope the concept is clear. If there's any question, feel free to ask in the comment section, and I'll be there to respond. Goodbye.